Ready, Nick? Here we go. Acceleration. What is acceleration? We're going to start out defining it, and then we're going to figure it out the long way, and then we're going to see if we can spot a pattern to see if there's a shortcut to get there. What's acceleration? Well, if you're speeding up or slowing down or changing direction. The fancy word, or the word that the phrase that summarizes all of that, it's when there's a change in velocity. Because velocity is a vector. It has both magnitude and direction. So you can change your velocity by speeding up or slowing down, or changing your direction, or doing both, speeding up, slowing down, and changing direction. The fancy phrase is it's the rate of velocity change per second. It's how fast your velocity is changing. But in this section, we're going to look at what we call constant acceleration. What does that mean, Ashley? I'm going to let you step on the brakes, or I'm going to let you press the gas. But once you've done that, I'm not going to let you step on the brakes harder or press the gas harder. Once we're accelerating, we're going to accelerate at the constant rate the whole time. If you have a changing acceleration, you really need calculus. We'll look at a couple of situations where there's technically a changing acceleration, but we'll kind of fudge things a little bit. So in this unit, we're looking at constant acceleration, which means that velocity change per second is constant. The units of acceleration are, well, it's the change in velocity per second. It's technically meters per second, but we don't write it that way since there's two S's in the bottom of the fraction. Meters per second squared. If you see meters per second squared next to a number, that's an acceleration. What is it if I see meters per second squared next to a number, Brandon? Squared. Good. Nick, I see meters per second squared and there's a number next to it. What might that be? Accelerate. Yeah. This is why it is worth memorizing what units go with what. It really cuts down on your thinking. Acceleration is a vector, but it's difficult to visualize or interpret its direction. So it's because we tend to confuse it with velocity. The direction an object is moving and the rate at which it is moving are both related to the velocity, not to the acceleration. To determine the direction of the acceleration, we need to watch it over a period of time and see how its velocity is changing. Let me give you an example. It says this: fill in the chart for positive 1.25 meters per second squared east. We're accelerating east. Which way are we accelerating, folks? East. Let's just call that positive. Keep it simple. And then we're going to look at three situations with our initial velocity. It's going to seem confusing at first. Don't panic. It'll become clear. So in the first situation, our initial velocity is 0 meters per second. What's our acceleration? 1.25 east, or positive 1.25. So here's what that means. Every second, your speed is changing by 1.25 meters per second squared in the positive direction. So after 1 second, now I'm going 1.25 meters per second. Anybody want to guess how fast I'm going after 2 seconds? Read. What about after 3 seconds? Keep the pattern going. What about after 3 seconds? Yeah. 3.75. For some reason, I went every other one black, so let's be consistent. What about after 1,000 seconds? Do I need to find the previous 999 seconds, or please God, let there be a shortcut? Second situation. Our initial velocity, VI, is 2 meters per second east. What's an easier way to write east? I'm going to call it positive 2. Okay? So we're going to start off at positive 2 meters per second. and our speed is changing by 1.25 meters per second every second in the positive direction. So how fast are we going after 1 second? It's a good question. What's our speed changing by every second? 1.25. So after 1 second, anyone want to guess? Someone's right. 3.25. We'll put a positive. That's our way of writing east. What about after 2 seconds? Yeah. 4.5? Is that right? What are we really doing? I think we're just adding 1.25 every second. Okay. So I think after 3 seconds, it would be, well, what would it be? And again, you can either do this in your head or use a calculator. I don't care, but what? Good. Positive, 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 east. So so here's what's happening. This first situation, we started at 0 and we're speeding up. So after 3 seconds, we're going that fast. You would notice this car is speeding up. This second situation, we didn't start at rest. We didn't start at speed 0, but you would say, oh, I saw a car, it was already moving, and I can see it's speeding up. Ooh, what about the third situation? What's our initial velocity? Lena, can you read to me where it says part C VI equals? What? What would be an easy way to show west? I like that. This one's a little trickier. So we're going to start off at -2 meters per second, but we're accelerating in the positive direction, 1.25 meters per second, 1.25 meters per second squared. So after 1 second, what will my velocity be? Read. I think of negative as backwards. So here's really what we're doing. If you want to look up for a second. I'm moving backwards at 2 meters per second squared. But which way am I accelerating? I'm looking for a word that starts with letter F. Forwards. So watch, it would look like this. I'm still moving backwards, but my speed is slowing down because I'm accelerating in the opposite direction of traffic. Okay with that? Ooh. Hey, what's my velocity after 2 seconds? Positive? Are you positive? Oh, sorry. By the way, here's what else that means. There's a lot of information packed in here. At time 1 second, I was traveling backwards. How do I know? At time 2 seconds, I was traveling which way? That means sometime between 1 and 2 seconds, there must have been a split second where I came to a stop and changed direction. It must have looked something, sorry for those of you at YouTube, but it must have looked something like this. I'm going backwards really fast, I'm slowing down, I'm slowing down, I'm slowing down, and then I start accelerating forward. All of that is still accelerating in the positive direction. When I was traveling backwards, accelerating in the positive direction slows me down. When I'm traveling forwards, accelerating in the positive direction speeds me up. After 3 seconds. Sorry? 1.75, is that right? Are you? Made a typo. Positive 1. Geez. Learn to write, Mr. Duke. Positive 1.75 meters per second. And again, what if I wanted to find it after 10,000 seconds? Do I need to find the previous 9,999 seconds? Is there a shortcut? I think there's going to be a shortcut. But are you kind of seeing what we mean by acceleration and why the direction matters? If your acceleration and your velocity are in the same direction, you're going to speed up. if your acceleration and your velocity in opposite directions are in opposite directions, you're going to slow down, probably eventually come to a stop, change direction, and then start speeding up. Next page. We're going to get a little bit technical. Don't panic. So whenever the velocity of an object changes, the object experiences acceleration. Remember, velocity has both magnitude and direction. So you can accelerate in two ways. You can accelerate if your speed is changing. That's what most of you experience when you're hitting the brakes or hitting the gas in a car. But you also accelerate if your direction is changing. You're accelerating when you're going around a corner, even if the speedometer isn't changing. Acceleration is defined as the change in velocity over the change in time. As an equation, we would write this. Acceleration, there's our brief. It's a vector, so I'll put a vector symbol above it. Equals change in velocity over change in time. Who remembers what's change in anything? It's on your green sheet. I think it's the first thing that I wrote. What was that? No, please read that very carefully. There's a symbol between it. Okay, so can we read, what's change in anything? I'm looking for the phrase final minus initial, right? Isn't that what it says? Certainly does not say initial final. No, it doesn't say that. Like on your sheet. Yes, y'all know what I'm talking about? First thing on the green sheet. I think I wrote it, did I not? Yeah. Change. So if I want to find the change in velocity, that's going to be V final minus V initial. And then technically it should be T final minus T initial, but we get really lazy. Time is always a change in, and so Ashley, we just stopped writing the time final minus time initial. It's just a lazy physics convention. What symbol am I using for acceleration? Lowercase a. What are the units? Well, technically meters per second, but we write that as meters per second squared. Scalar or vector, does it matter what direction you're accelerating? Will that change the situation? It's absolutely a vector. Now, this year, we're going to keep it fairly simple. We're going to let one way be positive and one way be negative. We're not going to get into really, really complicated vector mathematics. Next year, we will. Next year, you could be accelerating at 38 degrees north of west. Not this year. So velocity has the same symbol as speed. The symbol for speed is v. If the velocity at the start of the time interval is vi, initial, and the velocity at the end of the time interval is vf, final, then the change in velocity will be final minus initial. Reed, you agree with that? Good. If the time at the beginning of the time interval is ti and the time at the end of the interval is tf, the change in time is tf plus tf. So technically, this was the equation we would have written, but typically, we write it this way. vf minus vi over t, which we also put up there. Did I give you that on your green sheet? I did? Or no? Is there an A equals vf minus vi over t on your green sheet? I can't remember. Is there an A equals vf? I'm really looking for, because you got a bunch of equations. It's a yes or no question. Yes, I did, but I disguised it. Patience. Okay? Oh, Reed, what's change in anything? Hey, let's fill that. No, wait a minute. I'm going to abbreviate. You can write final minus initial if you want. Since velocity has two aspects to it, speed and direction, magnitude and direction, acceleration can occur if speed changes. That's the one that most of you are used to. You can feel it. Our bodies have a built-in accelerometer. It's just a backwards accelerometer. We'll talk about that later. If direction changes, going around a corner. Or both, if you're going around a corner while hitting the brakes or hitting the gas. In this unit, we'll mostly look at situation A. The magnitude is changing. Example 2. A runner accelerates from rest to a speed of 9 meters per second in 4.5 seconds. What was their average acceleration during this time interval? Okay. I don't know if you remember from last day, I said the first thing I always ask is, what are they asking me to find? What are they asking me to find? Okay. Now, this is Mr. Dewick being nitpicky. When you run, I don't think your acceleration is constant. I think it's bigger at the beginning and smaller at the end, but we can't deal with the changing acceleration. So when I'm trying to analyze a situation where I know the acceleration is changing, but I can't figure out the changing acceleration, I'll use the word average acceleration because that's technically what we're finding. We're just averaging it out over the whole trip. So whenever you see, if I ever do that for average velocity, it's my way of saying, look, I know it's changing and I'm a physics nerd and I have to say it correctly, just find the velocity. Or if I say average time, look, I know it's changing, just find the time. Or in this case, if I say average acceleration, I know it's changing, we're just going to find the acceleration. What's our symbol for acceleration? I'm going to write down A equals question mark. And now I'm going to read the question for numbers and physics phrases. And we've just been introduced to our first physics phrase. Everybody right now underline the phrase from rest. And in fact, that's a good habit to get into if you ever see the phrase from rest. Worth underlining because it tells us something. It tells me that my initial velocity is, as a number exactly, what? Yep. When I see from rest, I can say I know VI is 0. I see a 9.0. See it, see it, see it? What are the units next to that 9.0? So it must be a velocity. Is that my initial velocity or my final velocity? Gotta be final. You know how I know it's gotta be final? 2 ways. Number 1, I already know initial. But also read the time flow of the sentence. I think that 9.0 happened later. So I'm gonna go then actually there's a 4.5. What are the units next to that 4.5? What is that 4.5 a measure of then? Gotta be. The other thing, I did a quick check. Ashley, looking at all the units, are they nice or do any of them not match? In other words, is all the time units you see seconds or do you see an hours kicking around as well as a seconds? Is all the distances you see meters, or is there a kilometers kicking around as well as a meters? The units all match nicely. So as I'm reading, I'm also asking, am I going to have to do any conversions? No. Okay. I'm looking for an equation that has an A, a VI, a VF, and a T in it. Right now, you only have one equation, and the single equation that we have is acceleration is VF minus VI over T. Nick, what was VF as a number exactly? Yeah. What was VI? We wrote it down. Yep. Over. What was T? Now we're at the plug and chug stage. Get out your calculator. You might be able to do this in your head. I know that 9 divided by 4.5 is 2, but just to walk you through when it gets more complicated, can you all get out your calculator, please? If you don't have a calculator here, you want to sheepishly fess up and I'll give you a loaner. Y'all got your calculator out? How many of you have the fancy schmancy fraction button? Okay. You folks can hit that right now and you should have a 2-level fraction. The rest of us, is this a fraction? Yes. Is there more than one thing on the top? Yeah. Now I know there's a 0 and normally I would ignore the 0, but I want to walk you through an easier one so that when we get to the more difficult ones, this is how you would type it in. I would open up a bracket I would go 9 minus 0. I would close off the bracket, and then I would hit divided by. Again, those of you with your fancy schmancy fraction 2-level buttons can hit that instead. Is there more than one thing on the bottom? So do I need brackets around the bottom? No. If there was, I would open up a bracket and close it. And yeah, I know it's 2. You know what? Let's make it look really impressive. Let's go 2.00. We'll go to 3 sig figs just for giggles. Okay. Common mistake, by the way, look up. Kids go like this, 9 minus 0 divided by 4.5, and they say, oh, the answer is 9. No. You told your calculator to just divide the 0 by 4.5. You didn't tell it that also the 9 was part of the top of the fraction. What are the units for acceleration? And the direction, you know what? Is it positive? Let's just assume forwards because we're running and most people tend to run forwards. Turn the page. So again, the standard unit for expressing acceleration is meters per second squared. Meters per second per second. If an object is accelerating at 1 meters per second squared, that means each second its speed is increasing by 1 meter per second. If you're accelerating at 5 meters per second squared, that means each second your speed is going up by 5 meters per second. Example 2, a UFO is reported as accelerating from rest. I would underline the phrase from rest. What does that tell me? VI equals 0. Remember that. We'll come back to that. To 680 kilometers per hour in a time of 2.0 seconds. What is its acceleration? Ooh. Dan, what's this question asked me to find? Why is this question yuckier than the previous one? Can you see? Sorry? Units are yucky. We're going to have to do a conversion. Okay. We caught it though, yes? So you can't just turn your brain off when you're reading. You got to look at what's going on here. All right. So I'm going to do my usual A equals question mark. What was VI? How do I know? Okay. By the way, what if the question said came to a stop? VF would be, okay, or stopped, or something like that. So those are some physics phrases. This is why I said I'm looking for numbers and physics phrases. Often I'll see a 0 hidden in the question somewhere. So VF, I think, is 680, but that's kilometers per hour. What do I want to convert that to? Something to do with a 3.6. Now, if I can't remember, if you were away, I think you guys might have been away a couple of days ago, we added to the bottom of our formula sheet a conversion trick. So do you have the 3.6 on the bottom of your green formula sheet? You probably want to get that off of Jan or Reed or something in just a little bit. But for now, is it times by 3.6 or divide by 3.6? I can't remember. Divide, okay. 680 divided by 3.6. I get 188.88888888. Repeating? Yeah. Okay. Is this my final answer, or is my final answer acceleration? What are they asking me to find? So I'm not going to round this off too much because I'm going to be using this to find the correct answer. I would not round this to 190 because now I've introduced a whole bunch of error to the rest of my calculations. In fact, I'm going to write 188.9, but I'm going to store this on my calculator. And that's meters per second. My units are good, so I'm happy, Emma. What's that 2? Looking for an equation that has an A, a VI, a VF, and a T in it. There is one. Right now, it's the only one you know. It says this: A equals VF minus VI over T. It's going to be, 680? No. 188.9 is what I'm going to write. Minus, what's VI? all over 2. Is this a fraction? It is for me. Folks, here's what I'm going to write, though. Look up. I'm going to open up a bracket, and I'm going to hit my answer button, because that's VF. 188.888888888, and that way I'm not using a rounded off value to find another answer that's going to get rounded off. So a good habit, if you notice your value is stored on your calculator, use your answer button. And this is now the time, if you don't know where your answer button is, this is the time you want to ask me. Because otherwise you're going to start getting questions wrong when you did everything right, but your rounding was terrible. Everybody knows where their answer button is? Okay. -0, and I probably could have skipped typing that, but just to show you how it looks on my calculator, divided by 2, I get, you get 94.4? Now I'll go to 3 sig figs. Units, it's an acceleration. Yep. Mr. Dillek, how big is that? It's about 9 Gs. You could survive it, but you'd probably break ribs. We'll actually do a whole lesson on Gs, and you'll know what I mean by that. So if you're like, what? But that's a pretty big acceleration. Most of you, the most of you have experienced is about 4 meters per second squared or 5 meters per second squared. No, that's a fib. Playland rides, there is one ride on Playland where you pull about 40 meters per second squared. You pull about 4 Gs. I'm hoping that COVID restrictions next year will be such that I usually in Physics 12, we do a field trip to Playland and we go on the rides with instruments and we analyze them, because let's experience the acceleration instead of just talk about it. We usually do it in May. They actually run an amusement park physics day. They canceled it last year, and I have a feeling this year it might still be canceled, but I'm hoping. Good morning, you made it. This acceleration equation, how many variables does it have? Well, it's got an A, a VF, a VI, and a T. So how many variables? Do you know how many equations that actually is? It's 4 equations in one. You can memorize all 4 equations if you want. Please don't. What I'm going to start to do over the next couple of days is teach you how to rewrite these equations in your head to make them look any way that you want. It's going to seem a little terrifying at first. It's going to click at different rates for different people. I've done this before. As long as you don't quit on me, it will click for you. And so I really encourage you to buy into being able to do a little algebra in your head. We're starting it right now. There's other ways to write the equation. It says get the VF by itself. Let's start out by writing down our equation. A equals VF minus VI over T. And you know what? I got a little sloppy with my vector notation. I should have put a vector sign there, and I won't take marks off if you forget, but I'm a nerd. Okay. I have a fraction. Blech. First thing we like to do is get rid of fractions. What's this T doing on the right-hand side? Dividing. That's the same as doing what with a T on the left-hand side? So the first thing that I would do is I would go like this. Cross out that T and times it right there. You can write TA, but it's traditional to write AT. So that gives us this. AT equals VF minus VI. I'm going to stop writing the vector symbols for my work. I'll bring them in at the very end because it gets kind of cluttery. Callie, what does it want me to get by itself? VF. I know it's tough to see because I shrank it down. What side is the VF on? The left side's going to drop down like a domino then. Kuthunk. What else is right next to the VF of VI? What's the VI doing to the VF? Adding, subtracting, multiplying, or dividing? So how could I move it over to the other side? Except we're used to seeing the thing by itself on the left, so we typically write it like this. Do me a fave. Look at your green sheet. Did I give you that equation? That's why I said, when you said, Mr. Dewick, you didn't give us this equation on the green sheet. Yeah, I did. I gave it to you in the non-fraction form because kids like that one better. VF, V final, VF equals V initial plus acceleration times time. Or the way we'll typically read it, Nick, is we'll just say VF equals VI plus AT. Okay. What if I wanted to get the VI by itself? Well, it's way easier to start with this version of the equation. What side is the VI on, Liza? So the left side's going to drop down like a domino. What else is next to the VI? An AT, and that's lumped together. What's the AT doing to the VI? So? And then look up, don't write this down, look up. That equals VI, but do you mind, can I put the VI equals on this side, please? Because that's where we're used to seeing it by itself. This, Ashley, is what we're going to get really good at. Far better than you thought possible. And if you can wrap your brain around this, rather than having to memorize 1, 2, 3, oh, did I say get the T by itself? 4 equations, you can just look at this one, rewrite it in your head, and go straight to the punchline. How would I get the T by itself? Well, let's start with this one again. I'm not going to write the vector symbols, I'll bring them in at the end. What side is the T on? So what's going to drop down like a domino? The VF. What letter is right next to the T? What's the A doing to the T? So how will I move the A over? Remember that, remember that, remember that. What else is on the same side as the T? The VI. What's the VI doing to the T? How will I move the VI over? So I'm going to subtract the VI. I'm also going to divide by an A. The real question is, which order? You want the answer? It's reverse BEDMAS because we're going backwards and rearranging an equation. So you're going to do your adding and subtracting first. Then you're multiplying and dividing. Then your brackets. You're actually going to do your brackets last. We'll get to one that has brackets in it. So adding and subtracting first. I'm going to minus the VI. And then don't write this next bit down. Just imagine it. Don't write this down. Look up. I'll just imagine that there is an AT there, but I can just imagine that. What am I trying to get by itself? So how will I move the A over? That equals T. Although I'm going to go T equals on this side. So here's my argument. I can give you 3 things and you can find the 4th. I can give you any 3 of velocity initial VI, final velocity VF, acceleration A, time T, and you can find the 4th one. And then we'll eventually get into some nice applications. Next page. All of us have a built-in accelerometer. You can feel acceleration. You can. The only problem is it works completely backwards. Whichever way you feel the acceleration, I'm telling you, it's the opposite direction. Man, you're looking at me skeptical. I'll prove it. Ready, 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 ready? I'd like you to imagine, remember that you're in a car at a red light and the driver hits the gas. Okay? First of all, when they floor it, which way is the car clearly accelerating? Forward or backward? Forward. Which way do you feel like you're getting pushed? Your body can feel acceleration. It can. It just feels it completely backwards. So you feel like you're getting pushed but you're clearly accelerating forward. Or when a car hits the brakes and stops quickly, which way do you feel like you're getting thrown? Which way are you accelerating? You must be, because you're slowing down. How many of you have been on the elevator at Playland before? Okay, those who have been on it. When it shoots you up, which way are you clearly accelerating? Up. But which way do you feel like you're getting pushed? Yeah. Your body can feel acceleration. It just always feels it backwards. Oh, and then when the elevator shoots you downwards, you're clearly accelerating downwards, but which way do you feel like you're getting pressed? You feel like you're about to fly off your seat upwards. Yes? Good morning. So we said when it shoots you downwards, you feel like you're getting pressed up, but you're definitely accelerating downwards. There's a ride at Playland called the Music Express. It's the one that goes in a circle really, really, really fast. And then the DJ, how many of you want to go faster? And everybody screams, yay! I think it's right near the pirate ship. You know the one I'm talking about? Okay, those of you that have been on that one, when you're going in a circle, which way do you feel like you're getting pushed? Which side, inwards or outwards? So which way are you actually accelerating? Come on, take the punchline. If you feel like you're getting pushed outwards, which way must you be accelerating? Yes, yes. I have thought long and hard. I cannot find an exception to the rule. If you're on something and you feel the acceleration, you're feeling it backwards. So if you're ever asked, which way am I accelerating? If you can imagine writing that question and ask, well, which way would I feel like I'm getting pushed? It's the opposite direction. Trust me, it is. Now, the real question is, why is our body a backwards accelerometer? We'll explain that, but not for a few weeks. But your body is a backwards accelerometer. Have I convinced you? Okay. Example 4, I like example 4, I like example 4. Example 4 is a nice question. Read the question to yourselves. Okay, here we go. Raj, what's this question asking me to find? I saw you zoned out, so I went on you. What's this question asking us to find? V? What did you say, speed? Okay, which one, initial or final? And that part I have a tough time teaching. You're just going to have to read the question and the time flow of the question and ask, oh, are they asking how fast I was going before we started, or are they asking how fast I was going later on? So am I being asked to find VF or VI? That's the question. VF? I agree with you. So they must have told us VI. Raj, what's VI? How'd you get that? Oh, we should have underlined again the phrase from rest. That tells us VI is 0. What's that 4.5? How do you know? Even if they had crossed out that word, how would I know that that's an acceleration? Meters per second squared. This is why it really is worth memorizing what units go with what, because you almost reach a point where you glance at questions and, oh, I know what all that stuff is. What's that 3.6? How do I know? Seconds. Yep. Looking for an equation, got a VF, a VI, an A, and a T in it. There is one. It's this one. VF equals VI plus AT. What was VI? What was A? What was T? How fast are we going after 3.6 seconds? I didn't bother typing the 0 plus. You'll get 16.2. And I'll go to 3 sig. Oh, that already is 3 sig figs conveniently. Sure. 16.2 Verizon units. And I often put a box around my final answer. You don't have to. That's my spiking the football after a touchdown. It's just a habit. Okay. Look at example 5. I like example 5. I like example 5. Example 5 is a nice question. What's example 5 asking me to find? I don't think it's asking me to find VF. Where's the phrase that told you time? How many seconds? Also, why don't I like this question? Units. Blech. Okay, it's going to take some work, but we can handle this. So this would be information if you're designing safety roads and things like that, and you're trying to factor in driver reaction time to coming to a stop. How far in front of the stop sign do we need to put the stop sign ahead warning sign or whatever like that? So we can use this already in industry. It wants us to find time. What's that 110? What are the units next to that 110? Come on, what are the units next to the 110? So is that a time? No. Is that an acceleration? What is it? It's a velocity or a speed. Initial or final? Ooh, this time VI is not 0. So VI equals 110 kilometers per hour. Ugh. We got our green sheets out by now, I hope. Is it divide by 3.6 or times by 3.6? Divide? Okay. By the way, look up. In our notes, I'm writing all this out. If I was doing this in the homework, keep looking up. Nick, you too. I would just go like this. I would have crossed that out. I would have gone on my calculator, and I would have said 30.5, and I would have just written it right in, so I can't even accidentally write that 110 again. Less writing, more accurate, less errors. Whatever you want to do. In our notes, though, because we need to show what the heck we did, how we got that 30.5 repeating, let's write that out. And I'm not rounding that off if I can avoid it, because I'm using that to find my answer. Okay, I got VI. What's that 8? How do I know? Ooh. I got VI, I got A. That's only 2 things. I need 3 things to find the 4th. I guess I can't solve this. Or can I? What's VF? How did you figure that out? I should have underlined that. That's a physics phrase as well. Comes to a stop. So I'm looking for an equation that's got a T, a VI, an A, and a VF in it. There is one. And I think we even have one where the T is by itself. Do we not? You might have to turn back a page. I think it went T equals VF minus VI over A? Are you getting a weird answer? Those of you that have worked ahead, patience. There's a punchline coming as well, patience. But I like the fact that you worked ahead. So it's going to be 0 minus, I'm going to write 30.5, but what button am I going to hit? Yeah. All over 8. When I do that, oh, is this a fraction? Yeah. Is there more than a thing on the top? Yeah. So either fancy schmancy fraction button or brackets. 0 minus answer button divided by 8. What's weird about your answer? Time cannot be negative. We've made a mistake somewhere. For a candy, can anybody see the very, very subtle error that we made when we listed everything? And this is why I like this question. Read. Are we speeding up or slowing down? Hey, that's negative. That should be negative. Now, here's the nice thing. Your calculator did kind of tap you on the shoulder and say, I'm sorry, you can't speed up and come to a stop. The only way you can do that is in an impossible universe where we have negative time. So I do like the fact that tap, 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 your calculator got your attention. What that does mean, though, is if you ever get a weird answer, don't just say, it's right, or don't just say, I'll just throw away the negative. Ask why. You've made a mistake somewhere. So because I haven't hit equals, I'm going to go -8. You get the same magnitude as before, the 3.82 seconds, but positive this time. Is that right? Is it 3.82? Okay. So let's suppose that you knew you had a blind corner with a stop sign and you wanted to, am I wrong? No, there's a 9 after it. I used my answer button. I used 30.5555555. And are you starting to see why if you round off prematurely, you can get, especially often your third sig fig won't match my third sig fig. Okay? This you could use this if you're designing roads and it's a blind corner. You would say, okay, it takes people 3.82 seconds to come to a stop. I better put a stop sign warning sign on this blind corner at least 4 seconds in front of the actual stop sign so they know better start braking. Anybody here have a Tesla? Hashtag jealous. The new Tesla Model X can accelerate from rest. You know what? I would underline the phrase from rest. 30 meters per second in 3.2 seconds. Marcus, since you own a Tesla, what's this asking me to find? Okay. Do you see what I meant when I said physics word problems are easier than math word problems, in that it's pretty obvious what they're asking us to find? Write that down. Marcus, what's VI? How do you know? Oh, cool. What's that 30? Velocity or speed? Which one? Initial or final? So for the rest of the course, don't ever say speed. You need to tell me whether it's initial or final speed or velocity. How do you know? No. It's so obvious. It's tough. How do you know? Because I already found VI. It's got to be VF. Don't overcomplicate it. How did you know it was the velocity, meters per second? Yes? What's that 3.2? How do you know? Are all my units good, or were there any yucky units? Y'all understand what I mean by yucky units, right? Kilometers, hour, any yucky units? No? Let me plug and chug. I'm looking for an equation that's got an A, a VF, a VI, and a T in it. There is one. So I guess it's going to be 30 minus 0. Are we speeding up or slowing down? I'm expecting a positive or a negative acceleration. Okay? So you can make predictions ahead of time if you just visualize the situation. I owe you a candy, don't let me forget. Y'all get 9.37. Oh, if I go to 3 sig figs, I'll go 9.38. Is that fast? Pretty fast. About a G. What's your homework? So you can try these. Okay, there's 14 questions. Let me see. Maybe I'll nuke one. Let me see. I'll nuke number 4. Usain Bolt's old news now. Yeah, roller coasters are cool. Anybody been on California Screaming, or now what's called the Incredicoaster? Number 9, the numbers are accurate. I looked them up. So in case you're wondering what you're accelerating when it launches you, because it's a pretty good acceleration. So I think you can try these on a separate piece of paper. Let me pause for a second.